The lesson outcome for this video is I can quickly determine the vertex of a parabola by using vertex form. Okay, so obviously we're going to key in here on how we can quickly find the vertex of a parabola if a quadratic equation is in vertex form. What I have included right here in this snapshot here is actually two examples from the worksheet that we've done in class recently. And what I want to point out to you is that we did the work here to undo what's being done to the variable x so that we found our x-intercepts when y is 0. So when y is 0, we found our x-intercepts to be 4 and negative 2 for this example. And there's 4 here, and there's negative 2. And remember, we would add the 2 and divide by 2 in order to find our x value, where the line of symmetry would be, and the x value for our vertex. Okay, we've been doing this for a while, and we find out that the average of these two x-intercepts, if we add 4 plus negative 2, I did this work right here, we get 2, and then we divide that answer by 2 and we get 1. So the line of symmetry would be at 1, and that x value of that point, the vertex, would be 1. Then we put that 1 into the equation to solve for y, and what we would find is the corresponding y value was 18. So we said 1, 18 was our vertex. Now we did the same work down here for the second example, and I just want to point out that this time we found that negative 1, 16 was our vertex. Well, what I would like you to do right now is take a look at this vertex and this vertex of these two examples and compare that with the original equation. Do you notice anything? What I hope you notice is that this 1 and this 18 show up in our equation. There's a 1 right here, and there's an 18 right here. Same thing here, this negative 1 and 16. Well, there's a 1 right here. Now this is positive 1 and this is negative 1, just like this was negative 1 and this is positive 1. We'll talk about that in a second. And then 16. Okay? So that is how we are going to quickly determine the vertex of our parabola. We've been talking a lot about h and k in the work we've been doing. Well, here's the deal. hk is the point for our vertex. That is what h and k are in this form. What that means is we can very quickly look at an equation of a quadratic that's in vertex form and immediately tell our vertex. Now, because of this minus sign right here, things are a little bit tricky with this sometimes. The general form of an equation in vertex form has a minus sign here already. So then if our x value is positive 1, we plop that in right here as a 1. It looks like x minus 1. But the x value is positive 1. So right here, if it looks like x minus 1 in the parentheses, it's going to be a positive 1 for our x value. Okay, just like right here. When there's a positive 1 in our parentheses, x plus 1, we put a negative 1 in for our x value of our vertex. And then that other value of our vertex, the y value, is exactly what it looks like out here. So positive 18 goes here, and positive 16 goes here. And if this was a negative value, it would go in as negative here. Now, if that's a little confusing, we're going to look at some examples of this, so hopefully you will catch on. But first, a couple more things. Number one, we've talked a lot about A here and there in different lessons. I want to point out that A helps determine if the parabola opens up or down. Okay, opens up or down. And that is dependent on whether A is positive or if A is negative. And again, we've talked about that a little bit. So if A is positive, it opens up. And if A is negative, it opens down. All right, so A tells us if the parabola opens up or down. H and K tell us the vertex of the parabola. Let's look at some examples. So in these two examples, what we're going to do is just name what the vertex is. And again, the vertex is always going to be a point. And then we're also going to decide whether the parabola will open up or will it open down. Okay? So, if you remember from the previous screen, this number out here helps us determine if it opens up or down. Since this number A is positive, it opens up. Okay? So the parabola is going to be opening up in some way. Secondly, we know that our H and K value come from those two locations there in our equation in vertex form. Because the general form of the equation has a minus sign in it, H is positive 4, and K is exactly what this looks like, so positive 5. So our vertex is at 4, 5, and it opens up. Now think about how quickly we could draw a rough sketch of this graph now. Okay, there's a coordinate plane. If I have a point at 4, 5, well, over 4, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. So 4, 5 is here. That is the vertex, and it opens up. So there's our parabola. Pretty quick. And again, it's a rough sketch. It's not a perfect, I don't know how narrow or wide the parabola would be, and we can find that out, and we will in later lessons. All right, so go ahead and try this second one over here. Name the vertex and tell whether it opens up or down. Okay, so hopefully you said that it opens down, and it opens down because the A value here is -1/4. And then our vertex will be determined by the H value here and the K value out here. Now, be careful with this. In the parentheses it says x plus 6. That means our H value for our vertex is -6. Because what you can think of this as is x minus, because again the general form for vertex form has a minus sign right here. So x minus -6 squared. So then we know that H is -6. So again, kind of a quick hint is that if it says +6, it's going to be -6. If it says -4, it's going to be +4. So kind of the opposite of what it looks like in the parentheses there. And the K value for our vertex is 2. And again, it's just exactly what it looks like. So it says +2, so it does go in as a +2. Okay, so now on this screen what we're going to do is we're going to do kind of the opposite of what we were doing on the previous slide. And that is, instead of us finding HK, the vertex, and A from the equation, we're actually going to find them from the graph and put them into the equation. So again, this is the general form for our vertex form of quadratics. I'm going to actually give you the A value. Now this A value, I hope you realize for this example, would have been positive because it opens up, and the A value is 2. So what we want to do here is we want to fill in H and K right here, and then we want to write the equation for this graph. All right, so first of all, I'm going to find our vertex, and the vertex for this graph is right there, okay, in green here, and we want to name that point. So that point is at, if we kind of count over, at -3, -7. -3, -7. Because it goes from the origin left 3 and down 7 to get to that point. All right, so that's our vertex. We're going to go ahead and put that into the parentheses here. All right, and so now we're going to rewrite this equation with these put in the correct locations. Again, remember that this is H here, and this is K here. All right. So y equals the A value, which we found was 2. I actually told you that. And then, again, if H is -3, this would be x minus -3. Now, if you want to write that the long way and then simplify it, you can. So x minus a -3 squared, and then the K value is negative 7, so it's just going to look like negative 7 right here. It's just going to be negative 7. So again, I want to keep pointing out that the reason that that's a minus is because the original equation has a minus in it, and then if this is another negative, it's a minus a negative. So our final answer for this parabola, it's y equals 2 times x plus 3 squared minus 7. Let's try the second one here. If a is negative 1/2, all right, and now we want to find our vertex. So the vertex is right here, and that point is at 8, 3. Okay, so we're going to put the 8 here and the 3 here. All right, so we're going to write our equation y equals, our a value is negative 1/2 times the parentheses here, and it's going to be squared. So we have to put our 8 and 3 in here. So there's x. Again, if it says x minus h, it's going to be x minus the h value of 8. Again, this is my h, this is my k. So x minus 8 and then plus 3. That's our final answer here. Again, if it's x minus 8 here, that's because the h is positive 8. And then the positive 3 is positive 3. Go ahead and try this last one on your own. Check back to see how you did. Okay, so hopefully you found your vertex to be at this point here, which is 0, I was going to say 4, but it's 0, 3. So when we put it into the equation, again, this is 0, 3. And we're going to write our equation. Y equals the a value, our a value is 4, x minus the h value, well, the h value is 0, so x minus 0 squared, and then plus 3. Well, what's x minus 0? Well, x minus 0 is x, so we can write this as 4x squared plus 3. Now, because the parentheses were removed, because x minus 0 is x, it looks a little different, but it is still a quadratic. And you could look at this as being standard form, or you could think of it as being in vertex form. So that's another thing we haven't really touched on yet, but we will in the future.